Hello everybody and welcome to this, my corner of the internet. I'm SD Card and this is the fourth episode, I think it is now, in my series on OCR GCSE Computing. Today we're actually now into the second half of the syllabus, so yay, well done for getting this far. And today we're actually going to be talking about databases, okay? So let's get into this. So first question is, what is a database? A database is a persistent. It's very specific on the specification as to how we're meant to describe it. It is a database is a persistent, organized store of data. Okay, so basically, by persistent, it means that it's stored in secondary permanent storage. So it's not using the RAM. Not using the cache, but it's using the main secondary storage, so that it exists for as long as that hard drive exists. Okay, so data handling software has to be able to do four things, and those are to create, receive, update, and delete data from a database, and that creates the lovely the lovely acronym CRUD. So yes, I didn't make this up, this is what it says in the book. This ability to be able to manipulate databases is why companies tend originally buy computers, so they can organize their data and their users and their customers and data and everything, so they can use it more efficiently. So the simplest form of a database is a serial file, which is basically just where the data is listed. There's no order to it, it's just in a file and listed. So just simply so there goes, so you've got a serial file on the left there, and it's just random numbers. However, when you want to be able to have it, if you want to be able to find things in it more easily, it's actually useful to sequence it in some way. So let's say, for example, we order this list in order of size, so smallest to largest. That then becomes a sequential file instead of a serial file. So that basically means it's in a defined sequence. So again, once a data file has been sequenced in some way, it can easily be searched. Okay, so let's see. There are two main ways that databases are searched nowadays, and those are just basically on a item by item basis, and then something called binary searching. So the one on so this is an example of looking for the number 4 in this list. And the one on the left is the item by item basis. This is a natural name, it doesn't actually say what the name of the method is called in the book. But basically it just goes every single item in the list, starting from the beginning and going down, and tries to find the item that you're looking for. So in this case, it's the 4 is the 4th item in the list, and it takes four iterations over the list in order to find it. However, if you imagine that you had a list, let's say you ran an online business with millions of customers all using your service, then you'd have millions of things in this list that you'd have to go through, and that would take forever. The faster method is something called binary searching, which is what's on the right. I wasn't sure how to really draw this as a demonstration, so I've done my best. And basically, the computer decides on where to try and look for the data. So first, it will go to the middle of the data, not start at the beginning, but the middle, and then look at the input that's been given, and think, would the information I'm looking for be in the first half or the second half of the data? So in this case, is 4 greater than 3? If it then goes to the half that it's decided that the data will be in, and goes to the middle of that and says, will it be in the first half of this half, or will it be in the second half? So will it be and then it will continue doing that until it finds the data. So in this case, it's gone, is it greater than 3? Yes. Is it less than 5? Yes. And then it's found number 4, right between 3 and 5. This isn't a particularly good demonstration of it, but again, imagine you have millions of pieces of data that you're searching through. This is still faster than going through each individual thing. Okay, so another method that is used for searching databases is called indexing, and that basically, so each bit of data is referenced by a certain index. So in the book it gives the example of looking for the number 2005, and it has 4 different indexes, so 0, 1000, 2000, 3000, and so the computer would go to the index, find the number 2000, and then go and find 2005 in that part of the index. It would then look at the data that's attached to. So we've gone over sequential and serial data files, but the most common type of database that you'll use at school and is used for things like registers at school and for finding things is a flat file database. And basically it's the traditional split into columns and rows. So each column is what's called a field, which is a type of information, and each row is a different record, which is a collection of data referring to a specific item. So in this example, I've got a very simple address book. All the names are made up, and so are the phone numbers. So don't try calling them. So you've got the different fields of information, which are forename, surname, and phone number, and you've got different different records for different people. So yeah, that's all I can say for now about those. So right, let's see. Data redundancy is the unnecessary repetition of data. So let's say, so the example given in the book again is, let's say you run a company, and every time you run, for some reason you decide that every time a customer orders something from the company, they have to input all their data into the database all over again. You would then end up with loads of different copies of their information, personal information, which would mean that you could actually end up making mistakes. It's also incredibly inefficient because you're filling up your database's memory with the same data, so you're just repeating things over and over again. So data integrity is how well data reflects reality. So companies tend to try and update their databases fairly regularly to make sure that they still have all your correct information, so that they don't make as many mistakes. They also use validation techniques for when you're inputting data to make sure that it is correct first time round. And they've got a very helpful list in the book covering different types of validation checks. So you've got a digit check, which is where you run the digits of a bit of data through a calculation. So that this is usually used for barcodes and ISBN codes. Oh, pardon me, sorry. For when the company first receives an item, they'll give it a unique barcode and enter that barcode onto the system. And then when you purchase the item, they will scan the code and then put that code through a series of calculations to make, and then if it comes up with the result stored on the system, it will allow you to purchase it. Then there's the format check, so the data must match a certain layout. So UK car registration plates must generally follow the pattern of 2 letters, 2 numbers, and then 3 letters. So for it to be legal, and if you've got a personalised plate, it must follow that pattern. Length check, so the data inputted must be within a certain length, so either a set number or between a range. There's also lookup check, so so things like postcodes are subject to this. So the data is checked against an index of existing codes to make sure that the thing that you've entered does exist and can exist. You then have the presence check, which is where the input data is checked to see whether or not all the data that's needed is present, so that you don't have an incomplete data set. Then you have range check, which basically only applies to numbers, which means that a number must fall within a specific range. And then finally you have a type check, which basically means the data that's been inputted must be a certain type. So, for example, surname cannot contain numbers, and a true or false question cannot contain the answer to the question, what did you have for breakfast? Very loose definition there. So there are also verification checks to make sure integrity. There is integrity, and the slowest but most secure way of doing things is to force people to input the data twice. It will then check all the inputted data, both sets of data that you've inputted, to make sure they're the same. If there are any mismatches, then they'll ask you to do it again to make sure it's correct. Okay, so hierarchical databases are basically just... Okay, so I don't know how to explain this, but... Okay, so look at the image there. So the data is split into headings and things. Think of a family tree. So basically, you're related to so you're connected to the rest of your family through your parents. Okay. So the example, again given in the book, I'm using a lot of book examples in this video, as you might have noticed, is that you have a door, and the door has a hinge, and the hinge then has a bolt, and they can always split into different things. So the most common place you might come across this is when you're going through a computer file system. So for example, on my computer I have my username, then in my user section I then have a load of files. So for example, in the desktop file I'll then have a load of other files and folders and things that then contain more stuff, and it just kind of cascades down to a particular file. This isn't particularly useful for when you're storing data, because it's not very useful, but it's good for computer systems and stuff, because it allows you to easily sort things. Okay, so then a relational database. Relational databases use the flat file format. So if I go back to that, so they will look like this. It's the traditional way of doing things. So it has different columns and rows, each column representing a different field of information, and each row representing a different record. However, each flat file in a relational database represents a different entity, and basically an entity is a type of object that will have data stored about it. So, for example, one particular entity might be different types of cars. An entity might be bread. It might be people. It might be a cat, animals, anything. So each table in a relational database is a relation. Okay, so that's what they're called. Each table is a relation. Each have attributes, which are in the columns, so the fields, and they are distinguished by their names. So you've got, for example, in the example I showed you, it was forename, surname, and telephone number. Then each row is a new record, so that's general flat file stuff. Then Each row must have its own unique primary. Each record must have its own unique primary key, which is a unique way of identifying it from other things. So then you don't have any clashes of information. Each row has the same number of columns and the same data layout. So each column in the database I showed you earlier had 3 columns, a forename, and it was in the order of forename, surname, and telephone number. No telephone numbers first or anything like that. They're all in the same order with the same number of columns. Each file is then linked through foreign and primary keys. So a foreign key allows you to connect data between databases, so between files. So, for example, a cat will have many fleas, but a fleas will only have one cat. So the cat will have a foreign key relating it to the fleas database, and then each of the fleas in that database will probably have a column that has the primary key of the cat that it belongs to. So yeah, these are different relationship diagrams. So you have one to many, which is the cat to fleas. Then you have many to many, which is my example of videos to viewers. So I have multiple videos being viewed by multiple viewers, and then you have one to one, which is husband to wife. So in most cultures, you'll only have one husband to one wife. Okay, so when you design a database, it must have the following things. So it must have different fields, and each field must have what data type it has. So the data types I'll cover in detail. I think it's in the last episode of this series, so on programming. Just a quick overview is that the different data types are booleans, that's true or false, integer, which is only whole numbers, real numbers, which are decimal numbers, so things you might come across more often. Then you have strings, which are which are combinations of characters, whether that's numbers and letters, but they're all stored together. And then finally you have characters, which are single characters. However, in a database there might also be a date data type, so month, year, that kind of thing, so day of the week, yeah. You also have to specify the size of the field, so how much data is allowed to be inputted into each field of the record. So is that maybe 12 bytes or something like that. And then you also have to specify the validation rules. Do you want the range check, type check, etc. And then finally a primary key, which will distinguish it from all the other, the primary key field, which is the unique field that will distinguish it from all the other fields, all the other records. So this can either be the surname, the forename. It can be a unique value that the computer generates for you. It can also be a combination of fields. So maybe combining, let's say you stay at a hotel, it might combine your room number with your date of stay with your surname, and that'll be unique to you. Okay, so moving on. So most databases are organized by a database management system, or DBMS. So the database, the DBMS keeps data separate from the data separate from the applications that might use it. This that basically means that if multiple applications or maybe multiple systems, multiple computers are using the same database, then they don't conflict. They can all access the database without interfering with each other. So this maintains the integrity of the database, and it also allows you to make changes to the database without rewriting the entire database. So makes things a lot easier for the IT people. Okay, DBMSs also allow you to transfer data between databases. So data transfer on any database is known as a transaction. So if you think of it like when I make a transaction from my bank account to my friend's bank account, I'm transferring the amount of money from my bank account, which is represented by a database, to my friend's bank account, which is another database. And when a transaction does occur, it has to follow the rules, a certain set of rules, and these rules actually boil down to another nice acronym called ACID. Seriously, I couldn't make these up. So you have Atomicity, which basically means that either the transaction happens or it doesn't happen. So if you either have to be sure you want it to happen or you aren't. It'll ask you whether or not you want to transfer the data. Then you have consistency, which means that both before and after the transaction, the database must obey the validity rules that were set out when it was created. Then it must also then you have isolation, which means that if two transactions are occurring at the same time, they cannot interfere with each other. They must be completely separate, not mucking each other about or anything. Then finally you have durability, which basically means that the DBMS makes backups of the database, so that if there's an error or a power cut, then the database can be easily restored to what it was before something went wrong. Okay, so then you also have queries, which are basically when you interrogate a database, you ask it questions based on logic. So you say, a query will take inputs and use them to compare records to that input. So let me look for an example. So I have a database that contains the booking table for a hotel, and I want it to find all the records that have all the records for all the bookings that are for tomorrow, and where they all want breakfast in bed, and where they will be staying for 4 days. So the query will then go through the database and find me those things and present it. And you might be some databases will allow you to create queries using a programming language called SQL, and that basically allows you to very specifically define what you want to be what data you want to be found and how you want it to be found. And however, not everybody can use SQL, so therefore DBMS's not DBMS's, but database handling software provides something called forms, and forms allow the average user to input data and to query the database, so without too much trouble. And then finally, then you have reports, which are a report is the output of a query. So this can be either just a plain or a table on I don't know, in a PowerPoint, no, not a PowerPoint, in an Excel spreadsheet or something like that. Or it might be a very nicely laid out, smart thing that looks a little bit like this. So you have the different titles and things of the things that you're looking for and stuff like that. That has come up in the past. I think it was last year's paper that was one of the questions, or maybe a few years before, but I can't remember these things. Okay, then finally you have data mining. So data mining is the use of software to go through data to try and find connections. So a company, the most common use of this will probably be for a company like Google to go through search results and what people are looking for, to try and maximize the efficiency of their services. So a cupcake company might, an internet cupcake company might look through their data of orders to find out which types of cupcake people are looking for, are ordering most, and therefore to increase the production of those of that type of cupcake. The most useful results from a data mining campaign is when you come across unusual or unexpected results. Okay, so yeah, that actually brings us to the end of the section on databases. I'm not completely, I personally am not comfortable with this subject, so this has actually helped me a lot going through this. So yeah, that's it. So if you enjoyed this video or found it helpful or interesting, make sure you like and subscribe. If you can think of anybody else who might find it helpful or interesting, make sure you share it with them, because especially if they're doing this exam, they will probably thank you. So yeah, other than that, thanks for watching.